All right, on to our next page. We're done with temperature and we're moving on to heat. So heat is the energy of particles. Heat is always moving from hot to cold. Heat does not move from cold to hot. Heat is the energy of movement, so it's always going from hot to cold. So for example, a cup of coffee will cool down because the heat energy inside of the coffee is moving into the surrounding air. So anytime we're talking about heat, we use arrows to show the direction that the heat is flowing. And in this case, our heat is flowing from our hot coffee into our cool air. So the arrows are going towards the cold. Now you try. Draw in arrows that show which way the heat moves when an ice cube is placed in a warm room. So the warm room and the cold ice cube. And remember, heat always goes from hot to cold, never the other way around. All right, so thermal equilibrium is our next definition. And thermal equilibrium is when all the temperatures are equal. And that happens when the heat energy stops moving, and that's when thermal equilibrium is reached. And so in our example above, if our hot coffee, if all the heat leaves our hot coffee and goes into the cool air, it will stop, the heat will stop moving once the coffee and the air are the same temperature. All right, so thermal energy is our heat energy. And thermal energy is the amount of heat energy in a substance. And that depends on the temperature of the substance. And it also depends on the amount or the size of the substance. And so an example we have here is Shaquille O'Neal. He's a really big guy, so he has a lot of thermal energy. He has a high temperature, he's exercising, and he also has a lot of mass, so he has a high thermal energy. If we were to compare his thermal energy to someone, say, like Justin Bieber, all right, the two things we would compare would be temperature, which we know humans have a body temperature of 98.6 degrees Fahrenheit or 37 degrees Celsius, and also size to determine thermal energy. So here's a picture to compare the two in size. So Shaq would have a much larger thermal energy than Justin Bieber because he has the same temperature but is a much larger size. All right, so one more for you guys to try. There's 3 pictures on your notes: a cup of water, an ocean, and a swimming pool. And it says to rank the following pictures of water from the most thermal energy to the least thermal energy if they were all at room temperature. So if they're all the same temperature, which one would have the most thermal energy, the least thermal energy, and medium thermal energy?